In this video then, we're going to have a look at some questions based on intermolecular forces. Now, these questions are typically not just standalone questions, so intermolecular forces can be put into any question on organic chemistry. However, there are a few questions out there that just focus on describing and explaining what intermolecular forces give rise to certain properties. So this does link a little bit to periodicity. However, it's all to do with the forces in the particle. So hopefully you'll recall that the only type of compound that will exhibit intermolecular forces are simple covalents. Okay, nothing else is going to ever have intermolecular forces because there are no molecules. Okay, for an intermolecular force you need to have molecules. So ionic compounds, metallics, and giant covalents do not have these. So let's take a look at a couple of questions then. In this one, we've got group 16 hydrides, so that's just basically H2O, H2S, H2SE, H2TE. And our question is, the variation in the boiling point can be explained by intermolecular bonding. Explain why H2S, so this, again, bit of exam technique here. There's a lot of stuff going on here. Let's figure out what they actually want us to do. We need to explain why H2S has got a lower boiling point than H2O and H2SE. That means that you do not need to mention H2TE in your answer at all. You can ignore it for all intents and purposes. Okay, we're not interested in H2TE because it is not referenced at any point in the question. Okay, so don't bother trying to explain why that's high. I mean, you can if you want, but it really isn't essential to do. And you won't get any credit for it, so I mean, you're just wasting ink. Now, we need to ask ourselves, what are the intermolecular forces going on in these compounds? So clearly, water has a much higher boiling point than hydrogen sulfide, which is less than as well H2SE. Now, the first part of this question is very, very straightforward. And that is simply explaining why H2O has a higher boiling point than H2S. Now, hopefully, you'll have spotted, and obviously, H2O is a very, very common example of this. H2O, okay, has hydrogen bonds. Okay, H2O has H bonds. Okay, and they are very strong. And H2S does not. Okay, H2S, okay, does not have H bonds. Okay, in fact, all it will have is, well, it'll have London forces and it will have a permanent dipole interaction. But that's it. It stops there because you do not get hydrogen bonding with sulfur. You can only get hydrogen bonding with nitrogen, oxygen, and fluorine. So H2O has H bonds. That's your first mark, believe it or not. H2S does not. Okay, it actually has, well, you could either put London forces or permanent dipole. It doesn't actually matter. It has both. So you can have London forces or permanent dipole. It has both of these. Okay, because of the shape of the molecule. And then you just have to say the H bond is stronger, harder to break, something like that. So second mark will be H bond requires lots of energy to break. Okay, make sure that you put that in as well. In terms of exam technique, it's a very useful thing to realize. You do need to write down the relative strengths of the forces. So yes, you can say H2O has hydrogen bonds and H2S does not, but that is only worth 1 mark. The second mark is for saying that the H bond requires more energy to break it. That's why it's a higher boiling point. So that's explaining the boiling point. It's because the H bonds are stronger and require more energy to break. So that's the first part. The second part is slightly harder because you've got, well, I say slightly harder, more tricky. It's not immediately obvious because you've got H2S to H2SE. So you're going down the periodic table. So selenium is underneath sulfur and it's got a higher boiling point. Now you know it's got a higher boiling point, which immediately gives the game away. Okay, because there could be two things going on here. Okay, because I mentioned earlier that H2S has London forces and permanent dipole forces. H2SE will be the same. It will have London forces, it will also have a permanent dipole because of the shape of the molecule, okay? In case you don't remember, the shape of the molecule is a non-linear molecule, okay? So you'd have your S in the middle, your H is down here, and your bond angle would be 104.5, okay? So you've got, a delta negative, delta positive, you've got a non-symmetrical molecule, it would be polar, and it would have permanent dipoles. Now, normally what you're told, and what you're normally told, is the permanent dipoles are the stronger force. Typically they are, but not always. And this is where we have to consider the relative strengths of the forces. Now, luckily we have a graph to tell us, but we know that H2SE has a higher boiling point. Now, as you go down the group, as you go from sulfur to Se, if you remember the electronegativity scale, you will hopefully recall that electronegativity increases as you go up the periodic table and to the right hand side. Now that means that sulfur has a higher electronegativity than selenium, which technically means that H2S has got a stronger permanent dipole because sulfur is more electronegative, so those partial charges are slightly stronger. However, it is clear by the graph that this doesn't make a difference, which means you don't need to talk about it, okay? Because it's clear that even though H2S has a better permanent dipole, it's not helping its boiling point any. H2SE has a higher boiling point regardless, so it must be a different reason. And the reason is the other force, it's the London force, because as you go down the group, remember, London forces are related to amount of electrons, okay? The more electrons you have, the stronger the force. So as you go down the group from sulfur to selenium, you get a stronger London force. So your next part is basically saying that H2SE has stronger London forces because it's got more electrons. And you don't need to say anything else to get the mark. Of course, if you wanted, you could say it's the other way around. Okay, so reverse arguments are completely acceptable. You could say that H2S has weaker London forces because it has less electrons, and you'd still get the points. So 4 points, 4 marks, nice and straightforward. Ignore the permanent dipole argument, it's not worth getting into, but just for completeness, this is why we don't talk about permanent dipoles here, because it simply isn't relevant. Okay, it would only be relevant if H2S was higher than H2SE, because then it would be the permanent dipole causing it. But we know from our own knowledge, okay, that just because you've got a permanent dipole, it doesn't mean it's the strongest intermolecular force on offer. Okay, they will vary depending on numbers of electrons, and if you're comparing between compounds, you cannot use the comparisons. Okay, permanent dipoles, are typically stronger within a single molecule, but they're not always. Okay, and it's very, very clear when you go into some, especially lower down the periodic table, when electronegativity decreases a bit, and you get lots and lots more electrons when they start filling up the d and the f orbitals, that you do get a big shift towards London force as the dominant force. So don't be trapped into thinking that there's a clear hierarchy of forces. It's a guideline, and it definitely doesn't work when you're trying to compare them. Okay, different molecules do not have the same types of forces, and those forces will have different magnitudes. And we'll see this going into the next question. I'm going to skip this question. It's essentially estimating from the graph. So you simply have to find the relative molecular mass of polonium and extrapolate the graph. I'm going to do that very badly now. You watch this. I'm going to go straight line and then just sort of extrapolate up a bit, and then work out what the relative mass is. I'm not going to do that question. It's not worth doing. So this is the one I want to get through though, because again, it's another question. It's a very common question, and it's worth 5 marks. Okay, so boiling points of ammonia, fluorine, and bromine. They give you the boiling points, which is really, really useful. Okay, and they have to give you the boiling points, by the way. They can't expect you to memorize them, so they'll have to give you the data. And all you got to do is explain the different boiling points. But again, note the question. This is where exam technique comes in. You have to include the names of any relevant forces and particles. That's really important. And we'll get to why that is in a minute, because people normally forget this. So looking at them point blank, then what have we got? The best thing you can do here is just break your answer down. Okay, you explain the boiling points. Now it's not telling you it's intermolecular forces. However, you should be looking at these and thinking, well, simple covalent, simple covalent, simple covalent. Therefore, it's all about intermolecular forces. So this question is really asking you to explain the intermolecular forces and why it causes a difference in the boiling point. So let's jump into it then. First thing you do for your answer to get 2 marks, okay, and I would always do this, state it explicitly at the beginning. What are the forces you are looking at? So go through each one in turn and state what the forces are. So you need to make sure you get them right, obviously, but NH3, okay, we said earlier, okay, it's got hydrogen, it's got nitrogen. Nitrogen is electronegative enough for hydrogen bonding, so NH3 has H bonds. Fluorine and bromine are just halogen elements. They do not have permanent dipoles. They certainly don't have hydrogen bonding. So that means that F2 and Br2 both have London forces. That'll get you 2 marks immediately because you've stated the forces for each one. Okay, the explanation is going to be the important bit. Now, when you do this, again, this is what I said earlier about preconceptions on strengths of forces. Don't just assume that the hydrogen bond is the strongest force. Okay, it is the strongest force in NH3. When you start comparing it to other compounds, that might not be true. Okay, the London forces in a different compound can be stronger than a hydrogen bond in another, and this is one of those examples. Use the data. It tells you what the order is. All you've got to do now is rationalize it. Okay, it tells you bromine has the highest boiling point, ammonia is second, and fluorine is third. So write down your observations from that. So it's nice and straightforward. Okay, so ammonia, so NH3 is greater than F2 because the H bonds are stronger. Okay, that's straightforward, isn't it? And Br2 is better than NH3 because the London forces are stronger than the H bonds. Okay, London force is stronger than H bonds. You can write more electrons. Br2 has lots of electrons, and Br2 more E minus. Therefore, Br2 is also stronger than F2. That's it. Okay, that's most of the explanation right there. You haven't got to talk in great detail about it. You've got to make the comparison. Okay, NH3 is better than F2 because its hydrogen bonds are stronger. Bromine is stronger than NH3 because its London forces are stronger than the hydrogen bonds in NH3. And conversely, Br2 has more electrons, therefore it's also stronger than the London forces in fluorine by quite a stretch. Continuing on from that, one thing I will say, the mark that most people miss, okay, is in no point in this question does it mention what type of forces there are. So you need to mention at some point that all of these forces are between molecules. Okay, it's really important that because it's a mark that, and I've spelt molecule, I think my pen's just a bit weird there, but well, I'll just write it again. It went a bit dodgy there. So the forces are between molecules, okay, or write intermolecular forces, IMFs, okay. Make sure you say that because at no point does the question tell you this. Okay, so all I'm going to say in London forces and H bonds, but you need to explicitly tell the examiner these are intermolecular forces, i.e. between molecules, and those are the forces you're breaking. It may seem obvious, but the examiner's an idiot. Okay, assume they're an idiot, they usually are. Okay, you've got to make sure you tell them the obvious things because that's where the marks will be, and it ensures that you get everything out of the question. So otherwise, you might drop a mark here. If you don't write that, it's between molecules, you will lose a mark. So there you go then. I mean, in terms of this question, this is 5 marks. This whole thing is 5 marks. You do not need to put anything extra down. Note the number of lines. Again, we're not writing essays. Brevity is key in these questions. But there you have it. Okay, you can answer these questions very quickly. Again, bullet point your answer, make it clear to the examiner, and you'll pick up all the marks without any problems whatsoever.